Okay, this is an article in Nature, goes back almost 20 years, in 1999, and this is the abstract of sonoluminescence temperatures. Now, I don't know if I showed you yet, or I will later, but there's a graph that shows the temperatures relating to frequencies, relating to energies, and so forth. Now, look down here. This is an abstract. They're selling these papers. You have to buy all kind of information now. But I just go for the abstract because that's all I really need. Now, cavitation can produce white noise, sonochemical reactions, erosion of hard materials, rupture of living cells, emission of light, or sonoluminescence. I've been studying this deeply and I fully understand it completely 100% now. The concentration of energy during the collapse is enormous, and that is correct, because what it does is as the water expands and creates a cavity, it literally fills that cavity with electrons that it pulls out of the water. Electrons are nothing more than the same thing that happens in a circuit, and that's why they're talking about 10,000, 10 million kelvins, because it's nothing more than electricity. It's not just light. Okay, so listen, concentration of energy is enormous. The energy of an emitted photon, there is no such thing in their electrons, can exceed the energy density of the sound field by 12 orders of magnitude. This is free energy, and they just have no clue about it. They haven't used it. And I know how to use it. I'm almost positive. It's long been predicted that the interior bubble temperature reaches thousands of degrees Kelvin. Of course it does, because it's electricity. It's electric. All right? But experimental measurements of conditions, cavitation bubbles, are scarce. Now, this was 20 years ago. I think they're still scarce. Conditions inside the bubbles are scarce, and there have been no studies of interior temperature as a function of experimental parameters. So now they're just talking about it and they're writing a paper about it. But listen to this. This is what the key, and I don't think they understand it. Frequency is the key to every single different molecule. Every molecule has a different quantum state from the nucleus to the electrons. So some of them are this close, some of them out here, some of them out here, but none of them are in the same places. That's the key. If you can shake it in the exact distance to disassociate that particular electron level, and it won't do the other ones around it, it'll only do that one, you'll get anti-gravity, you'll get all kinds of these things that they're talking about, and crazy different things. And I've seen them, and I can show you these things, and I have videos on all these things. Now, listen to this now. The intense atomic emission allows us to change the properties of the gas-vapor mixture. The gas-vapor mixture. Change the properties of the gas-vapor mixture. What does that mean? That means that they can release, by changing the frequencies, more oxygen or more hydrogen or whatever they want inside the particular material they're working with, because the molecules have different frequency ranges, and if they hit the correct range, they can open it up and just disassociate that particular molecule. What that does, it allows them to change. So the change in the atomic emissions, that changes the temperatures. So listen, the property of the gas-vapor mixture, they can change it within that bubble. And thus, this is the key, vary the effective emission temperature of sonoluminescence from 51 to 2300 Kelvin. It's right there. All they have to do is change the frequency, and they're changing what is disassociated within that bubble, and therefore how much electrons it allows to collapse within that bubble. Simple as that. We observe emission temperatures that are in accord with those expected from compressional heating during cavitation. Okay, so they were frequency. They were changing it with frequency. I'm sure that's what they were doing, and these are the results, and it's pretty obvious. Okay, from the accelerator, which is down here, we get this distribution of light particles, and they are, each one is a particle. 1, 2, 3, 4, 5. The one in the middle is the highest energy because it made its way straight through the center instead of banging off one of the sides and being compressed. The other ones had a different energy level to them because they did not make it through as easily as this one. And this one became crushed in the total interior, I believe, and is the most energetic. So here's what we have. Very slightly energetic, a little more extremely, and then a little less, and so forth. Now, you see how they're expanded and then compacting at the end. All of them do the same thing. The accelerator sends them out in an accelerated state. They're going faster than they normally would. This is their normal state, or even maybe slower than that. These are all the same particle. This is a single particle taken and you see it in this strobe configuration. The reason you see the particle drifting to the left is it is spinning to the right, and that is the right-hand spin of particles is fully understood. It's called the right-hand rule. Now, if you look over to the right over here, this is what Harvard and the other scholarly people did to authenticate our work. They sent the same thing through, and their accelerator is this graphene plate with these gold wires, but it fulfills the same function. And they have a shower of acceleration in different spots here. So we had one that came straight through, so we can see very, very good detail. They're getting just sort of globular stuff coming out of here, which is similar, but not as descriptive. It's not as exact, but you can see exact same thing. You see the pulse, 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 and you saw it was on ours. The same. I mean, there's no difference there. You can see that, and that's the center one. So don't forget what you see here. And then less and less and less and less. You see over here, it's virtually identical. Well, it is identical. They come through their little plate, and they get all these accelerated particles. Then most of them coming through the center that are the highest, then a little less, and a little less. Same thing here and here. And you can see them, the same thing, they're spinning the same way ours are. Now, you get this trailing off here the same exact way you get it on the slit experiments, because light is coming down in this fashion. Okay, you see this here? The tip is the particle. Okay, light is coming down this way, spinning like this. As it spins down and hits the slit, if the back of the wave is coming through the slit, it is thrown off to this direction. If it is coming down and the front of the wave hits the slit, it's thrown off to this direction. Most of them, well, a lot of them will go straight through the center. That's why you get most of them here. The other ones are thrown in different varying degrees, and they collect out here. And each one of them collects as a particle, so that's fully understood too. They say, oh, they hit like a dot, 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 and over a course of time, you get a ton of dots here, not so many, and that's the way it works. It's as simple as this. All you have to do is look up these charts. You see up in here, atomic nuclei. This is frequency, how fast something is shaken. Up here in the distance of an atomic nuclei, which means you got the nucleus and then you got your little particles around here. And so it's shaken so fast here, the vibrations, that you're in the range of this distances. Extremely short, just Tesla distances. Tesla distances. Not radio waves and this and that, and even X-rays, and this is serious stuff. And look what are the temperatures? There it is, 10,000 10 million degrees Celsius up in here. 10 million Kelvin. That is electron. That isn't fire. That's electricity. Down here is your fire. 272 degrees, 173 up to, and then you're up in here where you're really you got some pretty serious frequencies going on, and all energy is more and more shaken. Tesla said it exactly 100% correct. Couldn't be more concise. It's nothing more than vibration. If this thing didn't move at all, you have no frequency, you have no heat. As you start moving, shaking, vibrating, the frequency starts increasing. The vibration is the frequency, and it goes up. As it goes up, the temperature goes up. Case closed. Totally simple. Tesla said it in, I don't know, half a dozen words, whatever he said. All right, here we go. Now watch, it's going to explode. When it does, it's going to start to create a cavity, obviously. See what's happening inside. Right about there, it stops. Now, this is going to fill with electrons. I'll stop this probably at some point. See this right here? I don't know if you can see that. But this is where the most intense cavitation was, and it's starting to fill with electrons where it's forcing open a hole. Well, the hole has got to have something in it. It's dragging electrons out of the water to fill this void. When it does, I'm not certain of the reason, but there's some reason that they cannot disassociate back from that cavity back into the water. It's either hydrophilic or hydrophobic action. Something's going on here that won't allow them to come back. That I can't explain, but I can see that they are not wanting to be allowed back in here. So let's follow this through and remember these things I'm telling you. Watch for all of the diamond-looking sparkles all around here. And Hutchinson says the same thing when he does his experiments with high frequencies. He sees little tiny glowing lights just like this all in his rooms, and then things start to levitate. He can do anti-gravity, and that's a fact. You look him up. I think it's John Hutchison. All right, here we go. Sonoluminescence, free energy in the making. All right, here it goes. Expanding. That's the inside. Look at what's happening here. You see the lights? Look at all of the electrons being dragged from the water in. You know the electrons can move very, very easily in water. Now, all right, now let's stop. It's reached its maximum. All right, and you can see these little, the electrons are here. Now the electrons are in there, and they cannot get out for some reason. That, I'm not sure what happens. But once they start to collapse, and you'll see the collapse happen here, you're going to see the external light here. So this will be obscured. You'll see it better in here, and then you'll see it try to force itself back into the water. And the water doesn't want it to come back. So here goes. Now, it's fully expanded. Now, the water is saying it's trying to force it back. This will start to boil. They literally boil. You see here? Look at those pockets, little boiling, just like it boils in water. You see that? It's boiling. You know, you could see the outside boiling, because this is happening inside as well. Now, at some point, it's going to get so bright in here that it can't maintain itself anymore, and then it will just vaporize. Here it goes. It's getting saying, oh, I can't hold it. Watch this. I'm going to stop it now. You see, whoops, and stop it again. You see this? That's like forcing itself. That is not being allowed back into the water. This is saying, I got to get out of this thing. How am I going to get out of here? Well, there's no way. I'm not letting you back in. And I can't explain that. But I can see that it just does not want to be allowed back in. It's saying, stay where you are. Now, when it does that, it says, well, I can't do anything other than reach bazillion degrees temperature because I'm nothing more than electricity. And I am just going to go out of here in a flash unless you let me get out of here. That's where I'm talking about. Put a wire in here. And it'll say, you're nothing but electricity? Well, I got a place for you over here in this air conditioner. Or I got a place for you over in this car or wherever it is. And here it goes. Poof, it's gone. It turned into light. See, it's out of there. Now that one's gone. That is the whole key of what's going on here. That, instead of going out of here a bazillion degrees temperature because it's electricity, why not take it as the electricity? Or maybe you can use it as the heat. There's another guy using sonoluminescence as heat. He's got a little tiny, what they call a resonator. It's nothing more than a little vibrator. Zzz, and it pushes the water and scrubs the water inside. And the water turns sonoluminescence into heat. the heat boils the water, and he does it with like a 9-volt battery, a little tiny thing. And I mean, it's extremely efficient, and I think it's actually can produce its own electricity to produce the vibrations that produce the electricity that produce the vibrations. And the vibrations produce more electricity than they do to make the vibrations. It said it's a 12 factors, factor 12. You got to be able to take 2 or 3 or 4 of those factors out of there to run your sonoluminescence, and then you're going to have another factor of how much coming out that's free. That's what free energy is, and that should be looked at, and I think it's a very, very serious possibility here.